This video we are going to see an example on superposition theorem. Here we have a voltage and a current source provided, and also we have a dependent voltage provided. So when we do the superposition theorem, what we do is we kill a current source in one circuit and we kill a voltage source in other circuit. So first, if I kill the current source, that's going to become an open circuit. If I kill the voltage source, that's going to become a short circuit. Now let's go ahead and do that. First, I'm going to kill this current source. If I do that, this circuit is going to look like this. So this is 2 ohm resistance, and we have 10 voltage source, and this is going to be an open circuit right here. And then here we are going to have 1 ohm resistance, and then here we are going to have this plus minus 2 ix. This is a current dependent voltage source. Okay, so let's say the question is asking us to find out the ix current. What is ix current? So if I say also I have to mention, the current passing through this is ix. So you know that this is 2 times ix, this is ix. So if this is ix, is this the current gonna be here? This is gonna be a little bit different here because since we are dividing, so I'm gonna put I prime x. Okay, this is one of the circuit. Like we kill the current source right here, and I'm going to draw another circuit. In that one, I'm going to kill the voltage source. If I kill the voltage source, this is going to be a short circuit at that point. Okay, so I'm putting the current source right here, and then voltage source is going to be short circuit, so it's going to be just straight line. And here we will have the resistor, and then current dependent voltage source. Let me hit this. This is a 2 ohm resistance, and this one is 1 ohm resistance. And then here we have the current dependent voltage source, that is 2ix. And we will have this current source also, that's 3 ampere going up. And this one is let's put I double prime x for this, because this is not the current that's going to be similar to this. So if this is 2ix, this is going to be a 2i prime x, and this is going to be 2i double prime x. Okay, and this is a short circuit right here. Okay, so we are interested in finding the current ix. So what we can do is, if I find the current here, I prime x, and if I find this current I double prime x, and if I add them together, that's going to give me ix. Okay, now let's see how we can use this new derived circuit. If I add these two together, we will get this circuit back. That's basically the superposition theorem. Superposition theorem is basically we are dividing the circuit into 2 different circuits and then solve them to make this one easier to solve them. Sometimes it might be an optimal choice, like sometimes it's not be the better choice, but when it's better, you can do this and solve problems. So here we are interested in finding the current. So for the first circuit right here, what is the best equation to use? Is KCL or KVL? You can see, like, we don't have any node right here. This is like a one loop circuit because this is an open circuit. So this is going to be just a one loop circuit. So when you have a one loop circuit, it's better to use KVL, because KVL says addition of the voltage in a loop, closed loop, is equal to 0. So if I use that, KVL is going to be equal to summation of V is equal to 0. So if I assume the I prime x is going in this direction, okay, you can take clockwise, counterclockwise, whatever you think thing you want. So if I take clockwise, that's actually better because the current direction also given in this way. So it's better to use, because if you choose the opposite side, you have to put a minus for it. So we don't want that. So if I choose this side, and then this is minus to plus, so that's going to be minus 10V. And then here I can apply the Ohm's law and write the voltage expression. V is equal to I times R. And here the current is I prime X. So this is going to be I prime X times R, that is 2 I prime X. And then here we have 1 ohm resistance, and since this is a one loop circuit, the current passing through, okay, this is a voltage, okay, so current passing through is going to be the same. So it's going to be I prime X here as well. I prime X times 1, that's 1 I prime X. And then here we have current dependent voltage source, and here the current is passing through positive to negative. So this is going to be a positive voltage, 2 I prime X. We have two unknown variables here. We have V. Okay, this V is a unit. Let me get rid of it. It's not, okay. So we only have one unknown where we can directly solve this. 2 I prime X, that's 3 I prime X, 3 I prime X plus 2 I prime X, that is 5 I prime X. 5 I prime X is equal to 10. I prime X is equal to 10. Therefore, I prime X is going to be equal to 5 divided by 10. 10 divided by 5, that is 2 ampere. Okay, this is I prime X. Now we still have to find I double prime X. That is from this circuit right here. In this circuit, which equation is better, KCL or KVL? You can see if I apply KVL, I need two equations I have to do for this loop and this loop. So it's better to use KCL because we just have one node right here, and we know this current entering from here is I prime X, and here we can put another current like ITX, something like that, ITX something, or IT. So if I do that, then if I apply KCL at that loop, KCL at, let's call this V, KCL at V naught. If I apply this node, what is the current entering here? Because KCL says summation of current entering inside of the node is equal to current summation of outside of the loop, outside of the node. So what is the current entering this node? We have I double prime entering, I double prime X entering this node, and then we have 3 ampere entering this node. So this is 3 right here, and then IT is exiting this node. Okay, so here we have two unknown variables, so we cannot directly solve it, but what we can do is we can write these things in terms of voltage. So I prime X, what's the voltage here? We put this voltage as V. So this, if this is going from here to here, and this is a reference voltage, whenever we have bottom, like in a circuit, the bottom part we already take as a reference voltage, that is 0 connected to the ground. Okay, so if the current is going from here to here, so high potential to low potential, so this is going to be 0 minus V divided by the resistance in between, those two. Okay, but here what we are trying to solve, we are trying to solve for the I double prime X, but okay, let's find the V first, then we can solve for I double prime X. 0 minus V divided by the resistance in between, that's 2, and then plus 3, and then IT, what is IT? Current is going from here to here, we assume this direction, so we have to put V minus and the voltage here. If it's plus, this is the voltage we are going to have here as well, 2 I double prime X. Okay, so V minus 2 I double prime X. Oh shit, okay, so I still gonna have two unknown. what I can do is, then I have to create another equation. Let's take this I double prime x separately, and that is equal to double prime x is equal to 0 minus v divided by the resistance in between, that is 2. So instead of v, we can put, we can put 2 I double prime x minus 2 double prime x minus 2 I double prime x. We can put that instead of, we can do the substitution. So this is equation number 2. So we can use it. If you have two equation and 2 unknown, we can solve it. Okay. And what do we have? We have it, that is going from here to, so v minus 2 I double prime x, and then divided by the resistance, that's divided by 1, so we can keep it as it is. Okay, now what we can do to simplify this one, we can multiply everything by 2 to get rid of this denominator. Yes, that's better. Let me create a new page and continue the lacking space. Okay, let me rewrite this equation. 0 minus v divided by 2, 0 minus v divided by 2, and then plus 3, and then we have v minus 2, that's equal to v minus 2 I double prime x. Okay, let's multiply the whole thing by 2. So this is going to be 0 minus v divided 0 minus v, and this is going to be 6, and then this 2v, and this is minus 4 I double prime x. So if I bring the v, if I bring this negative to this side, it's going to be positive for I double prime x, and then if I bring this negative to this side, that's going to be positive v. So 2v plus 1v, that's 3v, and we still have the number that is plus 6. Okay, now instead of this v, I can substitute this value, minus 2 I double prime x. Minus 2 I double prime x. In that way, I will make this one unknown variable. 3 times minus 2 I double prime x plus 6. If I do that, this minus 6 I double prime x, that is plus 6. Okay, let's bring this double prime x to one side. So 4 plus 6 I double prime x, that's 10 I double prime x, that's equal to 6. Therefore I double prime x is equal to 6 divided by 10, that is 0.6. Okay, let me see if I take the directions correct and everything. So first I got 0 minus v divided by 2, and then we have 3 going in, 3 going in, so these are added together. And what we had here, we had v minus this one divided by the resistance between. Okay, and then we had minus v divided by 2, and did we copy correct? Minus okay, we still have the minus v multiplied by 2, that's 2 gone, 2 in the denominator gone, this became 6, and this became, did we have this bv before? Yes, V minus 2Ix divided by the resistance in between. That's right. So if I bring this V to this side, that became 3V. And if we bring this negative 4I prime is that is positive 4, then instead of V we put the negative 2I double prime s. That's okay. And if I bring this positive, yeah, I don't see any mistake here. So here we have I prime x, that is 2 ampere. I double prime x is 0.6 ampere. So I x, different color. So I x is going to be I prime x plus I double prime x. That's what we put right here, because in superposition theorem, if you want to find a current, you have to find them both and add them together. So here we found the both of them. We found one of them to be 2 ampere and the other one to be 0.6 ampere, and that adds up to 2.6 ampere. And that's our final answer. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.